Hi all, just a quick video. I wanted to update you guys on the power supply design I've been working on. Some things or some learning curves I've gone through, i.e. Things catching fire, but I've got a solution to that. So yeah, let's get into it. It's going to be a short video, just a quick one to show you what I've been up to, what I've gotten on with. So if you guys have been following me on Twitter, there's my power supply initial first stage, the bulk capacitance stage. It takes the inputs, goes through a bridge rectifier circuit. You'll see some of the diodes are missing, and I'll get to that in a moment. This is a bulk capacitance for the two channels, the 36 volt channel as well as the 8 volt channel, 8.5 volt channel. So I assembled this entire board, put everything on, and I thought, let me just have a quick test. And I put my transformer onto this, started it up, and I only tested one of the channels at a time. So I put 8.6 volt on this side, plugged it in, turned it on, and the moment I turned it on, I got fire and some blue smoke escaping from my diodes. This drove me completely nuts, and I went through the design. I looked for short circuits on the PC board, looked if I had any diodes put in the wrong way around, and maybe created a short that way. But everything seemed to check out, and I couldn't figure out what the problem was. I did some research online, and I remembered Inrush current limiting. Now, this is a trap for young players, myself included. When you have a bulk set of capacitance like this, so this board in total at the moment has 6.8 millifarad on the one channel and 2.8 millifarads on the other side. So that's quite a bit of capacitance. And what happens is when you turn the power on initially, these guys are all empty, they're discharged. So that initial charge takes effectively, if you calculate it, there's ways to calculate it, and I'll put a link in the description for that. For the one that I used. As soon as you turn this thing on, I worked out with this set of capacitance, this board actually draws 370 amps, right? These caps can manage a surge current of about 70 amp, which is why, of course, they just caught fire, and actually they short circuit as well, or they blew short circuit as well, which is never a good thing. So I'll replace the diodes, and I'll potentially replace the caps as well. I have to test them just to make sure none of them actually got damaged in the process. So I came up with a quick temporary solution. I etched this myself just to test it. I'll have a nice board made for that as well. But the solution to this effectively is when you initially turn on your power supply, it should be running on through a set of resistors. So I've got 10 3 watt 470 ohm resistors sitting here. They each will reduce the initial current flow that goes through the system. As soon as the caps are fully charged, which happens after about 1.5 seconds, a relay on this board will clip in and actually short circuit the resistors, which means it'll initially allow the capacitors to just charge up slowly and then flip over, and you'll be able to then achieve full current, because once the caps are fully charged, everything's good, everything works fine, nothing explodes anymore, because by that stage we will be limiting and via the power supply's operation actually limiting it to 3 amps max and doing it like that. Right, so let me take you guys through a bit of the schematic and also how that looks in our 3D model. I'll take you through that and what that looks like. Let's have a look. Okay, so as you guys know, this is roughly what the components look like with the enclosure, etc. So what you'll see here is on our actual electronics, there's our bulk capacitance board, which I showed you guys. The additional board that I've done will actually sit just above that, and the transformer will then come in on these outside, the middle and the outside poles. These two additional poles over there are the ones that will match up directly with the ones below, and we'll have buzz bars going down there, which then feeds into the bulk capacitance board, which then feeds up to the control circuitry and the microcontroller interface, etc. So what the idea is here, as you can see, just roughly, there's these two sets of resistors, top and bottom node. This board will obviously sit a little bit higher, and we'll have 3 watt resistors sitting in parallel here, 10 of them for each channel, and the caps will actually load up through the resistors initially. So the relay that sits over here is normal open. So when you initially start this guy up, the resistors would actually load, or the caps will actually load up via the resistors to the normal channel. After 1.5 to 2 seconds, we can configure that after testing. The relay will clip closed, and we will bypass these resistors completely, and the circuit will be capable of full current. While the relay is open, the entire circuit will only be capable of about 1.5 amps as opposed to the 3 amps. So yeah, that's the idea, and obviously this then, as I said, feeds back to, or then feeds through to the bulk capacitance, which is now effectively our stage 2. It's no longer stage 1, which then will feed up via these bus bars to the control circuitry above. If we have a quick look at the schematic, it's really quick and easy. I'll bring in the board interface connector into this board, which is why it sits above the bulk capacitance board. And the reason for that is simply because we need a power good signal to come in and actually turn that relay on, so that it, as you can see there, literally bypasses or short circuits the resistors, so we no longer run through the resistors under normal operation. Quick board layout there. You can see, as I showed you earlier, there's our resistors, top and bottom loading, just to get them in to fit nice and snug. And yeah, that's the entire design. I'll probably be populating this second board soon, replacing my diodes and testing my caps, making sure that works. And yeah, then reassembling it all and see what happens from there on. Yeah, so you know, as a lot of guys say, hopefully your design does not work the first time, because that way you learn a lot. That's definitely been true so far. Luckily, so far the failures have not been too expensive. So yeah, onwards and upwards. So that was a quick look at what we've done. As usual, if you guys enjoyed this video, please give it a thumbs up. Any feedback is welcome. If you guys spot any other things that I've done that might set my desk on fire or something, please let me know. Any feedback welcome on this video. I've moved my lab around a bit, or my study. Let me know if you guys think this is better, worse, if I should go back to the old format. Yeah, feedback welcome. I always like to hear from you guys.